What happens on a microscopic level when a substance boils or freezes? In order to understand this, we will look at our favorite compound on Earth, dihydrogen monoxide, or more commonly known as water. You are probably quite familiar with water, since it would be impossible to live without drinking this precious liquid. But have you ever wondered what happens to this compound on a molecular level when you boil or freeze it? Through the next couple minutes, we will discover what happens at a molecular level when water freezes and boils. In order for us to understand what happens to water when it freezes or boils, we must consider the shape of the water molecule. I'll draw it here. Take note that it has one very electronegative oxygen. Now this oxygen is always trying to keep the electrons closer to it than the hydrogens that it is bonded to. This gives it a slightly negative charge due to the fact that the electrons are spending more time next to it. This results in the hydrogens having a slightly positive charge. So here we can see their positive charge. And why is this important? Well, this makes it much easier for water molecules to bond with one another. The hydrogen of one water molecule with its slightly positive charge can bond to another water molecule, oxygen, with that slightly negative charge. So now let's demonstrate what that bonding looks like. Remember, the hydrogen of one water molecule with its slightly positive charge can bond to another water molecule who has an oxygen with a slightly negative charge. These bonds are hydrogen bonds. These bonds are responsible for what happens when water freezes or boils. When water is at a normal temperature, these molecules are happily forming and breaking bonds. So what happens to the molecules when it freezes? Well, when you look at an ice cube, you can tell that the water has expanded when it's frozen. But why is this? Well, this is due, once again, to the hydrogen bonds. When water enters into its frozen state, the breaking and making of bonds that we talked about earlier slows down. This pushes the molecules into a lattice state that is just far enough apart to become less dense than its liquid state. You can see the empty space between the molecules. This results in the water becoming less dense, and this is why ice floats. What happens when water boils? Well, when we add heat to the water molecules start moving faster and faster. This has the molecules spreading out. Some end up spreading out so far that they form a gas. This is why there is bubbles when you boil water. Once again, it is important to remember that water molecules are always moving. When we add heat, they move much faster. If you add enough heat, they will spread out and form a gas that we know as water vapor. Notice how there is nothing between the atoms here, just empty space. This empty space is what forms the bubbles that rise to the top of boiling water. As we discussed, a water molecule is made up of two hydrogen atoms and one oxygen atom. The hydrogen and oxygen atoms of different water molecules are attracted to each other, and so they will stick to each other by forming bonds. It is important to consider these bonds when thinking about what happens to a substance when it boils or freezes. Remember, if we could use a microscope to look at a microscopic level of what is happening, we would notice that the water molecules are always moving and bouncing around. As a result, the bonds between the hydrogen and the oxygen atoms of different water molecules are constantly broken and reformed. When it is warm, the water molecules move and bounce around really fast. However, once it gets colder, the water molecules slow down, and as a result, the bonds between hydrogen and oxygen break less often and become more stable.